Hello students, so in the previous video we discussed some examples where it asked you to find the flow rate of an IV infusion, right, in either milliliters per hour or in drops per minute. So I do want to remind you that when you do the problems in chapter 10, okay, to round your answers to the nearest whole number, okay, if possible. So in other words, if you look at the answers in the back of the book for chapter 10, right, most of the answers are rounded to the nearest whole number. Okay, so with that said, real quickly before we go to the next two examples, okay, so I originally gave the answer to the first problem that we did in the last video as 41.6 milliliters per hour. So technically that's correct, but if you round that to the nearest whole number, right, it would actually be 42 milliliters per hour. Okay, so keep that in mind. Oh, and then likewise, I was quickly finishing up the other example in the previous video, and I don't think I got a chance to describe what was happening with the units. So essentially, what we did in the previous example in the previous video was that we took the volume of the fluid, which was 2,000 milliliters, and then divided by the time period, which is 12 hours, to get the flow rate in milliliters per hour. Okay, so since the problem asked for the flow rate in drops per minute, so GTT per minute, or GTT per minute, okay, we then converted the flow rate in milliliters per hour into drops per minute. Okay, and we did that by multiplying by the drop factor, okay, which says that 10 drops are in 1 milliliter. Okay, so we took 167 milliliters per hour, multiplied by 10 drops per milliliter, and that cancels out the milliliters. Okay, and since we want the flow rate in drops per minute, we need to cancel out the hours. Okay, so then we multiply by 1 hour over 60 minutes. So essentially, to get the answer of 28 drops per minute, right, you take 167, multiply by 10, and then divide by 60. And then when you round your answer to the nearest whole number, you get 28 drops per minute. Okay, so the next group of examples involve calculations for a flow rate adjustment. Okay, so here's the first problem. Okay, so it says that we have normal saline, 1,000 milliliters IV, right, to be infused over a 12-hour time period. Okay, and it says that the drop factor of the tubing is 20 drops per milliliter. Okay, so this problem has three parts. So in the first part, we're going to calculate the initial drip rate in drops per minute. Okay, so we're going to perform a similar calculation that we did in the previous example, okay, to get the flow rate in drops per minute in this example. Okay, so remember, flow rate is equal to the volume divided by time. Okay, so let's figure out the flow rate in milliliters per hour first. Okay, so we have 1,000 milliliters of normal saline, okay, being infused via an IV, okay, over a 12-hour period. Okay, so that's our initial flow rate. Okay, we're going to put that in our calculators. So 1,000 divided by 12. Okay, that's going to be a funky decimal, but let's go ahead and round it to the nearest whole number. So the flow rate in milliliters per hour is 83 milliliters per hour. Okay, and then what we're going to do next is convert the flow rate in milliliters per hour into drops per minute. Okay, like we did with the previous example in the previous video. Okay, so with the flow rate in milliliters per hour, we're going to multiply by the drop factor, which says that there are 20 drops in 1 milliliter. Okay, so again, the drop factor will depend on the tubing that you use. So for this particular IV infusion, okay, the tubing has a drop factor of 20 drops per milliliter. All right, so we're going to multiply our flow rate in milliliters per hour by 20 drops per milliliter. Okay, so in the process, milliliters are going to cancel. Okay, so 83 times 20 is 1660. So what this is 1660 drops per hour. So the remaining units are drops in the numerator and then hours in the denominator. Okay, so 1660 drops per hour. All right, next we're going to multiply by 1 hour over 60 minutes. Okay, so in other words, we're going to divide that by 60. Okay, to get the flow rate in drops per minute. Okay, so we have 1 hour in the numerator and then minutes in the denominator. So when we have the 1 hour in the numerator, that's going to cancel with the 1 hour in the denominator of the other fraction, drops per hour. Okay, so in other words, the flow rate is 1660 drops per hour. So we divide that by 60 to get the number of drops that the infusion is taking place per minute. So with 1660 divide by 60. Okay, and again, round that to the nearest whole number, so that's approximately 28 drops per minute. Okay, for this particular tubing, so 28 drops per minute. Okay, so that's the initial flow rate of the infusion in drops per minute. Okay, so this is the initial flow rate in drops per minute. Okay, so the next part of the question says, when the nurse checks this infusion 7 hours later, it says that 500 milliliters are left in the bag. So this is an abbreviation, LIB, which stands for left in the bag. So 500 milliliters are LIB, left in the bag. Okay, so we want to recalculate the drip rate for the remaining 500 milliliters. Okay, so to answer this question, we want to answer two questions. So after 7 hours, how much time is remaining for the infusion? So remember, the original order said that the infusion was taking place over 12 hours. Okay, so after 7 hours, right, we have 5 hours remaining. So 5 hours are remaining. Okay, so once we understand how many hours are remaining, and then the amount left in the bag, we can use that to calculate the new drip rate. So then the second question is, right, what is the new drip rate? Which is what the question is asking. Okay, so again, recalculate the new drip rate by taking the remaining volume, which is 500 milliliters, and then dividing it by the remaining time, which is 5 hours. Okay, and you can do a quick mental calculation. So 500 divided by 5. Okay, or put that in your calculator. So 500 divided by 5. Okay, and that's 100. So that's equal to 100 milliliters per hour will be the new flow rate. Okay, so then we then want to convert that into drops per minute to get the new flow rate in drops per minute, the new drip rate. Okay. So once again, we do a similar calculation that we did in the previous part of the problem. So we're going to multiply by the drop factor of the tubing, which was 20 drops a minute. So 20 GTT, I'm sorry, 20 drops per milliliter, not per minute, but 20 drops per milliliter. So 20 GTT over mLs, okay, over milliliters. Okay, so the units of milliliters cancel. Okay, what I'm going to do is I'm going to do this as one calculation. Okay, you can break it up if you'd like to. So you can do 100 times 20, and that'll give you the number of drops per hour. Okay, but since we want this in drops per minute, we're going to multiply by 1 hour over 60 minutes. Okay, so the units of minutes are going to cancel in the process. Okay, and we're left with, I'm sorry, the units of hours are going to cancel, sorry. Units of hours will cancel. The units of drops will remain in the numerator, and then the units of minutes will remain in the denominator of our final answer. Okay, so what we're doing is we're taking 100 Okay, multiplying by 20 and then dividing by 60. So we multiply by whatever's in the numerator and then divide by whatever's in the denominator. Okay, we're not going to multiply by 1 because multiplying by 1 has no effect. Okay, and then the milliliter and the denominator fraction here is 1 milliliter. Okay, in other words, divided by 1 has no effect. So 100 times 20, okay, is equal to 2,000, and we're going to divide that by 60. Okay, so we're going to round that to the nearest whole number, so 33 drops per minute is our new drip rate. Okay, in the last part of the question, it says, if the facility protocols indicate that flow rate adjustments must not exceed 20% of the original rate, right, may the adjustment be made? Okay, so there are a couple of ways you can approach this, but I think an easy way to do it is, okay, let's figure out what 20% of the original rate was. Okay, so the initial flow rate was 28 drops per minute. Okay, so let's calculate. Okay, so let's start by calculating. So calculate 20% of the initial flow rate of 28 drops per minute. Okay, so what you're literally going to do is you're going to take 20%, all right, and multiply it by 28 drops per minute. Okay, and when you multiply by a percentage, okay, remember you got to convert that percentage into a decimal. So when you convert 20% into a decimal, it becomes 0.20. Okay, so in other words, take the percentage and divide it by 100. So 20 divided by 100 is 0.20 or 0.2. Okay, we're going to multiply that by 28. Okay, so we could do that on our calculator. So 0.20 times 28 is 5.6. Okay, so any flow rate adjustment that we make, right, cannot exceed, in this case, for this particular infusion, cannot exceed 5.6 drops per minute. Okay, I'm not going to round that to the nearest whole number, right? We want to be super precise here. Okay, so that's like the maximum adjustment rate that we can make for this particular infusion. Okay, so it is the maximum adjustment rate we can make for this infusion. All right, so now let's calculate the difference between the new drip rate and the old drip rate. Okay, so the new drip rate to complete the infusion ended up being 33 drops a minute. Okay, so the difference then, the difference between the new drip rate and the old, or I should say, or the initial drip rate is, so it's going to be 33 minus 28. Okay, and you can do a quick mental calculation or put that in your calculator to be on the safe side. So 33 minus 28, okay, is equal to 5. Okay, so which is 5 drops per minute. Okay, so 20% of the initial drip rate for this infusion was 5.6 drops per minute. And the difference between the new drip rate and the old drip rate ends up being 5 drops per minute. Okay, so long as the adjustment and the flow rate is less than the maximum allowable adjustment for the particular infusion, you're going to be okay. Okay, so the adjustment is okay. So the adjustment is okay. Okay, since it is less than 20% of the initial rate. Okay,